Tonight you're going to eat something soft, something cooked, something that took you less than a minute to chew before you swallowed it. You won't think about it. You never do. But 2 million years ago, a meal like that didn't exist. Every bite your ancestors ever took was raw, tough, and fighting back. What do they actually eat? The real answer is far stranger than meat or berries. It's a story about a body that had to change shape just to survive its own dinner. Picture it. Not a campfire. Not a cooked haunch of meat turning on a spit. Strip that image away completely because it's wrong for almost the entire span of human evolution. For millions of years before anyone controlled fire, your ancestors were animals chewing raw food in the open, competing with hyenas and vultures for scraps, and slowly, brutally, evolving a body built around that struggle. Start with the jaw. Your jaw is small, weak compared to a chimpanzee's. A chimp can crack open nuts and grind fibrous plants for hours a day using jaw muscles that anchor high on the skull, sometimes even connecting across the top in a bony ridge called a sagittal crest. You don't have that ridge. Your muscles are smaller. Your molars are smaller too. And yet your ancestors survived and even thrived on food that was tougher than anything you eat today. How? Run your tongue along your own back teeth for a second. Flat, blunt, practical, but not built for heavy-duty grinding. Now imagine handing yourself right now a raw wild yam straight out of the ground, fibrous and starchy and unyielding, or a chunk of raw zebra muscle, cold and tough and resistant to every bite. You would struggle. Badly. And that struggle is the whole point of this story, because your ancestors didn't just struggle with that same food. They built an entire evolutionary and technological system around solving it. The answer starts with what was actually on the menu. Before fire, before agriculture, before anything resembling a kitchen, the human diet was built on 3 unglamorous pillars: raw plant matter, raw animal tissue, and a food source most people forget entirely: underground storage organs, roots, tubers, worms, things dug out of the dirt with sharpened sticks and bare hands. Anthropologist Richard Wrangham spent decades studying exactly this question. He wasn't just curious about what early humans ate. He wanted to know why their bodies looked the way they did. Wrangham's research, most famously laid out in his work on the cooking hypothesis, pointed to something uncomfortable. Raw food, even meat, is expensive. Not in money, in energy. A raw diet takes far longer to chew, far longer to digest, and yields far fewer usable calories than a cooked one. If your ancestors were eating raw roots and raw meat for millions of years, they were spending a staggering amount of their day just processing food to survive. How much time are we talking about? Look at modern chimpanzees, the closest living proxy for that ancient raw food lifestyle. Chimps spend roughly 6 hours a day chewing. 6 hours. Not preparing food. Chewing it. Now compare that to you. You spend under an hour a day eating, total, prep included. Something happened between the ancient raw food ancestor and you. Something changed the entire economy of eating. Before that change, though, there was a diet, and it was resourceful in ways that might surprise you. Early hominins were not picky. They ate fibrous leaves and stems when nothing better was available. They ate fruit when it was in season, which, unlike the sugar-bred fruit in your grocery store, was often small, fibrous, and barely sweet. They cracked open nuts using stones as early tools, a behavior still observed today among chimpanzees in West Africa who use rock hammers and anvils to break open hard-shelled nuts. And crucially, they dug. Digging opened up an entire underground pantry that most animals couldn't access. Tubers and roots store enormous amounts of energy because that's their biological job. They're the plant's savings account, holding starch and water underground where fire, drought, and grazing animals can't easily reach them. For a hominin with hands free to dig and a mind clever enough to remember where the good patches were, this was a reliable, calorie-dense food source available even during dry seasons when fruit was scarce. Some researchers argue this shift toward underground foods may have been one of the most important dietary pivots in early human evolution because it offered a fallback that didn't depend on the whims of a fruiting tree. Notice, too, what digging required physically. A chimpanzee's hand is built for climbing and swinging through branches, curved and specialized for grip on a moving vine. A hominin hand, freed up by walking upright on 2 legs instead of 4, could be put to an entirely different kind of work. Gripping a sharpened digging stick. angling it into hard-packed earth, levering out a route that might be a foot underground, protected by soil and animal, without tools simply couldn't break through efficiently. Bipedalism and tool use didn't evolve in separate stories that happened to overlap. They fed each other directly. Standing upright freed the hands. Free hands made tool use possible. Tool use unlocked food sources, like buried tubers and marrow-filled bone, that a four-legged forager physically could not reach. Each piece of this system reinforced the others. Then there was meat. Not steak. Not anything close. Early access to meat likely came first through scavenging, not hunting. Picture a hominin standing at the edge of a lion kill, waiting, watching, moving in only once the big predators had eaten their fill. What was left behind wasn't the meat itself, most of the time. It was bone. And inside that bone was something almost nobody else could reach. Marrow. This detail matters more than it sounds like it should. Marrow is extraordinarily calorie-dense, packed with fat, and critically, it's sealed inside bone that most scavengers can't break open. A hyena's jaw can crack bone. A vulture's beak can't. And an early hominin, holding a stone the way you'd hold a hammer, could smash a femur open and access a food source most competitors simply couldn't touch. Some of the oldest confirmed tool use evidence in the archaeological record isn't for hunting. It's for exactly this: cut marks and percussion marks on ancient animal bones, showing that early humans were processing carcasses for meat and marrow long before anyone controlled fire. Picture the scene honestly, without the dramatic music. Not a bold hunter bringing down prey with a spear. A smaller, slower-moving hominin, watching from a distance as lions finish a kill, waiting for the moment the big cats wander off to rest in the shade. Moving in quickly. Grabbing what's left, mostly bone and connective tissue. Carrying it somewhere safer, or working fast where it lay. This was dangerous, opportunistic, and completely unglamorous. But it worked, and it worked specifically because of a resource almost nothing else could access: the fat locked inside bone. That fat wasn't just calories. It was the specific kind of dense, easily absorbed energy a growing brain needed most. There was also a smaller, quieter category of food that rarely makes it into the popular story: insects. Termites, ants, grubs, beetle larvae. Modern hunter-gatherer groups still eat them today, and for good reason. Insects are surprisingly rich in protein and fat. They're available year-round in many environments, and unlike a fleeing antelope, they don't require a coordinated hunt to catch. Some researchers who study early tool use point to specific bone fragments worn smooth at one end that look suspiciously like early termite fishing tools, the same basic technique modern chimpanzees still use to pull insects out of a mound one at a time. It's not a glamorous food, but glamour was never the point. Reliability was. Reliability, in fact, might be the single most important word in this entire story. A hominin body didn't evolve around the best possible meal. It evolved around the worst realistic case. What can you eat in a drought? What can you eat in a season with no fruit? What can you eat when the herd has moved on and the other predators got there first? Underground tubers answered the drought question. Marrow answered the lions already ate everything else question. Insects answered the nothing else is around today question. None of these were exciting. All of them kept a body alive long enough to keep looking for something better. So the raw diet wasn't starvation. It was resourceful, technical, and physically demanding. But it came at a steep cost, and that cost is written into your body right now. Anthropologists Leslie Aiello and Peter Wheeler proposed something called the expensive tissue hypothesis, and it directly connects to this raw food problem. Your brain is enormously expensive to run. It makes up about 2% of your body weight, but consumes roughly 20% of your resting energy. Something had to give elsewhere in the body to afford that. Aiello and Wheeler's argument was that as diet quality improved, richer in fat, richer in usable calories, the gut could shrink, because a smaller, less energy-hungry digestive system was enough to process a higher quality diet. That freed up energy budget, they argued, may have helped support the growth of a bigger, hungrier brain. But shrinking the gut only works if the food coming in is dense enough and soft enough to be processed efficiently without a massive fermenting chamber of an intestine. Raw plant fiber alone can't do that. Raw meat and marrow, rich in fat and protein, move things in the right direction. But there was still a hard physical bottleneck standing in the way, and it wasn't digestion. It was chewing. This is where a 2016 study led by Catherine Zink and Daniel Lieberman becomes so revealing. They wanted to know exactly how much easier food became to eat once you did two things separately: slice raw meat with a stone tool and pound raw underground plant foods to break them down mechanically. Using electromyography to measure real jaw muscle effort while people chewed raw versus prepared foods, they found that simply slicing meat and pounding tubers, no fire involved at all, dramatically reduced how much chewing force and how many chewing cycles were required. In other words, before your ancestors ever cooked a single meal, a sharp rock alone was already doing some of fire's future job. It was pre-digesting food, mechanically, outside the body. This matters because it reframes the whole story. The leap from raw food to modern human bodies wasn't one single moment. It was layered. First, bigger brains needing more calories. Then a scavenged marrow and dug-up tubers providing denser, more reliable energy than raw fruit and leaves alone. Then, stone tools slicing and pounding that food into something the jaw and gut could handle with dramatically less effort. Cooking, when it eventually arrived, wasn't the beginning of easier eating. It was the final, most powerful chapter in a process that had already been underway for a very long time. Think about what this means for the timeline you probably grew up picturing. Most people imagine a straight line. Raw food, then fire, then civilization, as if each stage flipped a switch and the next one began. The truth is messier and far more interesting. Stone tool use likely stretches back more than 3 million years, long before any confirmed evidence of controlled fire. That means for well over 1 million years, maybe closer to 2 million, early hominins were already engineering their food. Slicing it, pounding it, cracking it open, choosing which bones to smash and which roots to dig. This was technology, in the truest sense of the word, applied to solving a biological problem long before flame ever entered the equation. Fire didn't invent the idea of processing food to make it more digestible. It simply became the most powerful tool in a toolkit that already existed. There's a modern experiment that makes this same point in an unexpectedly direct way. Researchers studying long-term raw food dieters, people today who deliberately eat an entirely uncooked diet, heavy in raw fruits and vegetables, for health or ethical reasons, have found something striking. Even with modern, selectively bred produce, softer and sweeter and far easier to digest than anything available to your ancestors, long-term strict raw foodists frequently struggle to maintain a healthy body weight, and many experience disruptions to normal reproductive hormone cycles. This is happening on a diet that is, in almost every measurable way, gentler than what a Pleistocene hominin faced. If modern raw eating, using modern produce, still struggles to supply enough usable energy for a modern human body, it puts into sharp perspective just how demanding true prehistoric raw eating must have been, and just how much clever engineering, mechanical, and eventually thermal, it took to keep a hungry, growing-brained hominin fed. And you can still see the fingerprints of that raw, tool-processed diet on your own skeleton, if you know where to look. Your teeth are smaller than a chimpanzee's relative to your body size, but your molars still carry the kind of enamel and wear patterns suited to a diet that, for most of its history, wasn't soft. Your jaw muscles are weaker than an ape's, evidence of a diet that had already been mechanically softened before it ever hit your mouth. Your gut is short, compact, energy efficient, a legacy of a diet that shifted toward calorie-dense, easily processed food long before flame entered the picture. There's something almost humbling in this. You imagine primitive eating as crude, brute force survival. Rip, tear, swallow. But the reality is closer to the opposite. The pre-fire human diet was a masterclass in resourcefulness under pressure, reading the landscape for buried tubers, understanding which bones held marrow and how to break them open, using stone tools as an external, portable set of teeth long before anyone learned to control flame. It wasn't a diet of desperation. It was a diet of intelligence applied directly to survival, one raw meal at a time. Consider how much specialized knowledge this actually required. Knowing which roots were edible and which were toxic without the ability to boil out harmful compounds, something cooking would later make dramatically easier. Knowing the seasonal map of an entire territory well enough to predict where a fig tree would be fruiting weeks from now, or where a dry season tuber patch could still be dug even after everything above ground had withered. Knowing how to read a half-eaten carcass and judge, in seconds, whether the bones inside still held marrow worth the risk of lingering near a kill site where a leopard might return. None of this was passed down in writing. It lived in memory and observation, in the accumulated trial and error of countless individuals who didn't survive the mistakes so that others could learn from them. Every successful raw meal was really the visible tip of an enormous, invisible base of ecological knowledge. And that knowledge didn't stay static. It compounded. A hominin group that remembered where 3 separate tuber patches were located and roughly when each one ripened had a buffer against bad luck that a group relying on memory of just one patch didn't have. A group that had figured out the angle and force needed to crack a femur cleanly, rather than shattering it uselessly, got more calories out of the same carcass than a less skilled group. These were not dramatic leaps. They were small, cumulative advantages, the kind that don't look like much in any single generation but reshape a population over hundreds of thousands of years. This is, in a very real sense, the beginning of culture, not campfire storytelling yet, but practical, food-driven knowledge passed from one generation to the next because the alternative was starvation. So the next time you sit down to eat something soft, something that barely requires your jaw to work at all, remember what stands behind that ease. Millions of years of hominins digging with sticks, cracking bone with stones, reshaping their own skulls, their own guts, their own daily rhythm around the sheer physical labor of turning raw material into usable energy. Fire gets the credit in most stories about how humans became human. But the truth is that your body was already changing, already adapting, already outsourcing the hardest parts of eating to tools and cleverness long before the first flame ever made a meal soft. Tonight, when you eat something soft, something cooked, something that took you less than a minute to chew, you're not just enjoying a meal. You're tasting the end result of millions of years spent solving the oldest problem your species ever faced: how to eat enough to keep a hungry, growing brain alive.